Greetings from my recording studio somewhere near Japan. In this video, we'll be looking at the Order of Operations Agreement and specifically why the operations are given the priority they're given in mathematical situations. To start, let's go ahead and define what an operation is. We know what an operation is when we go to the hospital, but we're really speaking about mathematical operations here. And for us during this video, we'll be talking about addition, subtraction. We'll represent multiplication by a dot. That's called the dot product. Division can either be represented like that. It can be represented as something like this or something like that. We'll also be looking at exponents, roots like square roots, and then groupings like parentheses, brackets, curly brackets. So whenever we're talking about mathematical operations and the order of operations, what that means is that we assign certain operations a greater priority in a sequence of operations. Operations need to be done in a particular order to get a required outcome. So why do we have this agreement? The simple answer is simply to get the right answer. We can write an equation in different orders. We can have addition first, subtraction later, multiplication, division, square roots. And if we do them in a haphazard way, we can get lots of different answers. So we're going to determine why we've established a certain priority sequence of operations. And that is so that we get the right answer. And there are reasons that the order is given in the way it is. Before we get too far into it, let's go back a little bit, maybe to grade school, middle school, and talk about different types of numbers. All right, for us, there's going to be two types of numbers. One of those is going to be called scalars, right? And then the second type of number we're going to be looking at is called physical quantities. For us at this time in our mathematical career, scalars are just going to be numbers like 1, 2, 3, 4, counting numbers, numbers that we use in everyday life. In juxtaposition to that are physical quantities, and they're represented as two-part expressions. A physical quantity will have a numerical value. That's the number right there, and it'll also have units like this. That's 2 dogs. Typically, we don't see it, but there's a multiplication sign between the numerical value and the units. Going all the way back to grade school, we have scalar addition. We just add two numbers like 3 and 4, and we get 7. Now the nice thing is we can do something similar to that with physical quantities. We just have to be a little bit more careful. So here's a situation. We have 2 dogs, 2 dogs, and 2 dogs, and we're going to add those. And it's probably immediately obvious to the most casual observer that we have 2, 4, 6 dogs. But now what happens if we have this situation. We're still talking about addition. We have 2 dogs plus 2 dogs plus 2 horses. What do you think the question mark is in this case? The best we can do whenever the units are different is we can add the similar units. We get 4 dogs and 2 horses. Notice that we don't combine the numerical values whenever the units are different. You probably heard this back in grade school. You can't add apples and oranges. That's exactly what that means. If the units are different, you don't combine the numbers. Now let's look at this situation. We're starting to move into actual calculations now. So look at this for a second and tell me how many dogs you have. There's a couple of different ways of getting this information, but we can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So at the end of the day, with all of this, we're going to have 11 dogs. Perhaps you did that a little different way. Perhaps you wrote an equation like this. So we had 4 groups of 2 dogs plus 1 group of 3 dogs, and we know that our answer, just from counting, is 11 dogs. But whenever we write the equation like this, we have an option. We can either, perhaps we might choose to add 2 dogs and 3 dogs, and we would have 4 times 2 plus 3 equals 4 times 5 equals 20 dogs. That didn't give us the right answer of 11 dogs that we just counted. Let's go back and look at that. So instead of adding these numbers first, let's go ahead and do the multiplication first and see what we get. So 4 times 2 dogs is going to be 8 dogs. That calculation's finished. Now we're going to add the 3 dogs to it. And that gives us exactly the number of dogs that we counted. So what we've just shown is that multiplication, this multiplication here, has priority over this addition here. Right? So multiplication has a greater priority than does addition. So let's review for a second. To add physical quantities, the units must be the same. You can add apples and apples, but you can't add apples and oranges. I mean, you can put them in a dish together, but you can't combine the numerical values. And then secondly, we've learned that multiplication has a higher priority than does addition. So having learned that multiplication has a greater priority than addition, let's move on to exponents. Here we have 5 squared, and just as a review, that 5 is called the base. That superscript number is called the exponent. And that exponent just tells us how many factors that we have whenever we do this operation, 5 squared. is simply two 5s times each other. 5 to the third power is just 3 factors of 5 times each other. Now, let's go back and look at this. 4 times 24, 4 times 25 equals 100. We can write 25 as 5 times 5, and that still equals 100. But we can write 5 times 5 as 5 squared. And since 5 squared equals this, this answer here still has to be 100. So let's look at what we're going to do. Let's choose to do 4 times 5 first and then square it. So 4 times 5 is 20. And then we do the square. That's going to equal 400. That didn't give us the answer that we know we have to get. So we come back and we do the 5. We square that first. That's going to be 4 times 5 squared is 25 equals 100. So what we've just shown is that exponents have a greater priority than does this multiplication. So far, what we've shown is that exponents have a greater priority than does multiplication, and multiplication has a greater priority than does addition. Okay, moving right along, we'll now look at groupings such as parentheses, brackets, curly brackets, I don't know what those things are called, square roots, cube roots, and other types of groupings, either explicit or implicit. To start off, let's look at 14 divided by 7. We know that equals 2, but we can write this number as the sum of 2 other numbers and this 7 as the sum of 2 other numbers. Let's go ahead and do that. 14 is the same thing as 8 plus 6 divided by 3 plus 4, and we know that has to equal 2. This is called a case of implicit groupings. That would be the same as writing parentheses around these like this. And the reason that we use parentheses is to specify that we have to do a particular operation before another one. So sometimes it's not always obvious which ones that we have to do depending on how the problem is structured. So moving on to this next line here, we have essentially the same numbers. We have 8 plus 6 here. Instead of having a horizontal division line, we have a diagonal line, and below that we have 3 plus 4. This can be a little confusing here. If we use the order of operations that we have so far, and it says that multiplication has more priority than does addition, and since division is just the multiplicative inverse, the answer to this, if we did it just using the order of operations that we have so far, this would be 8 plus 6 divided by 3 is 2 plus 4, and that's going to be 4 plus 6, 4 plus 2 is 6 plus 8 is 14. But that's not the answer we want, given that this was the original problem. We can force this into giving us the answer 2 by putting parentheses around that and saying, okay, we have those parentheses. We want you to do the operation inside the parentheses first before you do anything else. And if we do that, we'll have 8 plus 6 is 14. We'll keep that diagonal division bar. And then 3 plus 4 is 7. That looks exactly like that, right? So the reason that we use parentheses is to tell whoever's working this problem, give priority to the things that are inside the parentheses. It's an agreement that we as mathematicians have, that if you want to specify something having greater priority, then put it in parentheses or brackets or curly brackets. Well, that's just about it. Let's go ahead and summarize what we've seen. We've gone through a derivation of the order of operations showing why certain operations have priority over others. And we've seen that groupings, right? We've always agreed that groupings such as parentheses, brackets, and things, we agree that those operations, whatever in there, is to be done prior to anything else. And then just below that were exponents. Right below that was multiplication. And then finally addition at the lower end of everything. Now, we haven't talked about division and subtraction, but division is defined as multiplying by the inverse of a number, and subtraction, we've seen in other videos, is simply adding the opposite. Guys, thanks for your attention. Thanks for learning. And here at the end of the day, there's only one thing left to say, and that is